Hi everybody, welcome back to the Feynman Technique. I have decided to kind of take this channel in a new direction, at least for a little while. Um, I've been kind of running out of ideas for new Feynman integration videos, and I've just basically been redoing old ones in that new format that you've seen lately. And I'm going to continue to do that, don't worry. But what I'm going to start doing now is I'm going to be going through all of the available past AP Calculus AB um, exams from 1999 to 2022. And I'm just going to be doing them one question at a time on my videos. Each question has four parts. These are going to be the free response questions. There's other parts to it, but they're not as challenging. So this is the part that most students struggle with are these free response questions. So I'm going to be going over how to solve them in detail, starting with problem one on the free response portion of the examination from 1999. And this is actually the one that I took. Um, this is the test that I took, so I actually remember this problem. I didn't do very well on it, by the way. I took it again and did a little bit better. But when I first took it, I didn't do very well. I was a little bit cocky and thought I could get by without studying, and guess what? You can't. You need to study for this stuff. So anyway, here is question number one. It says, a particle moves along the x-axis with velocity given by the y-axis. Yeah, that's important. It's moving up and down. So a particle moves along the y-axis with velocity given by v of t is equal to t times sine of t squared for t greater than or equal to 0. And I wrote that up there. And this is part A. In which direction is the particle moving at t is equal to 1.5 and why? Well, how do we know what direction it's going? It moves along the y-axis, and it says um, with velocity given by, and I forgot to write that up there, along the x-axis, I should have, with velocity given by v of t, and velocity in terms of time is equal to t times sine of t squared for t greater than or equal to 0. In which direction? Okay, how do we know what direction it's moving? Well, if if the velocity is positive, this thing is going up. If the velocity is negative, this thing is going down. And luckily, they already gave us the velocity function. So this is the simplest one of the questions. You literally just have to plug in 1.5 into your function v of t there. So basically, you just put 1.5 times, well, I'll use the big boy version of times, sine of 1.5 squared, and that's roughly equal to, according to my notes, 1.167. Okay, is the velocity, in which direction is the particle moving and why? Well, this is a positive number, therefore it is moving in a positive direction. On the traditional xy plane, up indicates positive movement. So it would be moving up. It is moving up. And why? Because 1.167 equals v at 1.5, which is greater than 0. And that should get you full points on that test. It is moving up because 1.167 is equal to, well, I should actually say we should use this little squiggly equal sign for full points, is roughly equal to v at 1.5, which in turn is greater than 0. And if it's greater than 0, the thing is moving up. All right, part B. Let me erase this. Find the accelerate. Okay, bam, accelerate. I'm not even going to read the rest of that. As soon as I see acceleration, this is something you have to know. If you see acceleration, you have to know. Study this. Mark this down. If you don't know it, write it down. Acceleration is the derivative of the velocity function. We have the velocity function here already. So find the acceleration. I stop reading. I'm going to find the derivative of that thing right away. And I'm going to call it A in terms of t for acceleration at a time. And that is equal to the derivative with respect to t of v of t, which is equal to what? What do we have here? What rule for derivatives? We have a product rule. So this is how I like to set up product rules. I recommend you do it the same way. I just put a parentheses, another parentheses, and then plus a set of parentheses and another set of parentheses. Okay, why did I do that? Because we know it's going to be the first times the derivative of the second plus the second times the derivative of the first. Your calculus teacher may have taught you the derivative of the first times the second, and then, the other way, but it's all the same since it's just separated by an addition sign. So I use first times derivative second plus second times derivative first, because that's how I learned it. So that's why I put those 4 parentheses right there. So what is our first function? T. What is the derivative of our second function? Well, we have a chain rule, and really we should do this out step by step, but I'm going to skip that. Our inner derivative is 2t, right? The derivative with respect to t of t squared is 2t times the derivative of the outer function. Well, the outer derivative is cosine times cosine of what? T squared. That stays the same. All right. Plus the second sine of t squared times the derivative of the first, which is just 1. So we'll get rid of that. And then all together, this is going to become a 2t squared cosine t squared plus sine of t squared. Okay? So always do it step by step like that. If you see a product rule, set it up the way I just had it set up. It'll make your life a lot easier, and you won't get it wrong. Okay. So find the acceleration of the particle at t is equal to 1.5. All right, we have the acceleration function in terms of t. So what we want is a of 1.5. And I'm not going to write that out. You plug in 1.5 for t into this thing, and you get roughly negative 2.049. By the way, a calculator is required, or at least allowed, on this part of the examination. Okay, so what does it ask? Find the acceleration. Okay, we found that. Is the velocity of the particle increasing? Well, what does the velocity increasing means? That means is the rate of change of the velocity positive? No, it's not. This is the rate of change of the velocity function right here. It is the derivative. Derivative is the rate of change, and it is negative. Therefore, the answer is no. You would say no because v prime of 1.5 is less than 0. There you go. That should get you full points. You might want to put v prime of 1.5 roughly equals negative 2.049. 9, which is less than 0, and then, have that be your final answer? No, because, v prime, which is the rate of change of the velocity, is a negative number. And therefore, the velocity is not increasing. Okay, on to part C. And usually these things get more and more difficult as you go from A to B to C. That's generally how it works. A good test-taking strategy is, if you are not sure how to do something on this test, skip it. Don't spend the whole time trying to do something that you probably can't do. You're going to get stuck on one or two of these questions, probably, if it's your first time taking it. All right, so part C. Given that y of t is the position of the particle at time t. Well, that's, okay, y of t is the position. What are we given? We're given the velocity. This is, again, this is a kind of a physics concept. You have to know that velocity is the derivative of the position function. So, if velocity is the derivative of the position function, what is the position function in relationship to the velocity function? It is the antiderivative of it. So, y of t is the antiderivative of the velocity function. Okay, so y of t is the antiderivative represented by that integral sign. This is an indefinite integral of v of t dt. And that is equal to the indefinite integral of this, which is t times sine of t squared dt. Okay. So that is the most basic form of our position function. I mean, that in essence, that's what it is. Okay, and all right, we need this part. Y of 0 is equal to 3. Therefore, if you plug in, once we figure out what our y of t really is by taking this antiderivative, we know that if we plug in 0 for t, the output is 3. All right, so first, how are we going to take the antiderivative of this thing? All right, well, I'm going to borrow a concept from Black Pen, Red Pen called Wouldn't It Be Nice If? And it would be nice if we had a 2t there instead of a t, wouldn't it? Because then this 2t would be the derivative of this t squared. So what we're going to do is we're going to put it there. We're going to put that 2t right there. But we can't just do that, can we? We just multiplied this whole thing by 2. So we actually need to have a 1/2 there. All right. So I hope you would agree that's still the same thing. We just multiplied it by 2, and then we took 1/2 of it. So it changed nothing. Then you're going to have to know kind of these basic integration techniques also. If you're not familiar with the u substitution, get familiar with it. Our u substitution in this case is we're going to make a substitution. U is equal to t squared. And now there's a lot of different ways that calculus teachers like to do this. A lot of them like you to take a derivative with respect to t on both sides, giving you du dt is equal to 2t, then multiply both sides by dt. I just like to take the derivative directly. The derivative of u is 1 du. The derivative of t squared is 2t dt. And it's more proper to say the differential of u is du. And the differential of t squared is 2t dt. So however you do it, this is what you should get. All right. So nice. We have this t squared. That's going to become a u. And luckily, we have our du already in the form 2t dt. It's right there. 2t dt. Don't forget, this is all multiplication. This is 2t times sine t squared times dt. So just pretend this 2t is to the right of that sine t squared, and we have our du. So y of t is equal to 1/2 the integral of sine u du. Okay, what is the antiderivative of sine u? Please don't say cosine u. It's not. It's negative cosine u. So this is equal to 1/2 negative, and I'll put the negative in front of the 1/2, cosine of u. All right, we're done, right? No, we're not done. Don't forget the plus c. When you were learning this stuff, you probably didn't understand why you needed the plus c. You're going to need it here. And we're also not done because we want y in terms of t, but we have y in terms of t being something in terms of u. But we know what u is. U is just t squared. So that's it. Y of t is equal to negative 1/2 cosine of t squared plus c. And I'm going to put a parentheses around that. All right, now comes the part where we use this. We have our y of t, but we have this plus some arbitrary constant. So basically we're saying y of t could be basically anything as long as it had this form. But we know it passes through the point 0, 3. If we plug in 0 for t, we get out 3. So let's write that. We have y of 0 is equal to 3. I'm just copying that directly. But also, what is y of 0? It's also equal to this thing when t is 0. So we have negative 1/2 cosine of 0. What is cosine 0? You have to know that. You have to have memorized, or at least be able to tell me that the cosine of 0 is 1. So we have negative 1/2 plus c. Well, if 3 is equal to negative 1/2 plus c, what is c equal to? Well, let's make this 3 a 6/2, and then add 1/2 to both sides of this equation, giving us 7/2 is equal to c. And now we can just copy that right here. 7/2. So y of t is equal to negative 1/2 cosine of t squared plus 7/2. All right, find y of 2. Simple. Now it is, anyway. Y of 2 is simply plugging in 2 for that t right there. So y of 2 is equal to, what did I have in my notes here? It looks like it is 3.827. 3.827 units. Okay. And that's it. That's all it asks. It literally asks you for just a numerical value for y of 2, and we have found it. All right. Now comes what should be the hardest part of question 1. Find the total distance traveled by the particle from t is equal to 0 to t is equal to 2. All right. Well, distance traveled, as long as you're going in one direction, the same direction, is going to be the integral from when you start, the time when you start, to the time when you stop of the velocity function. But what if the velocity goes to 0 and then goes negative and then goes to 0 again and goes positive. And what if there's a bunch of intervals in there where it does that? You have to count negative movement as a positive value when you're talking about the total distance traveled. Because if I walked over here and then stopped and then walked over here, you wouldn't say I traveled 0 distance, would you? No. I traveled the distance from here to there, then from there to here. That's total distance traveled. If they had said find the total displacement of the particle from t is equal to 0 to t is equal to 2, then you could do that. You could just integrate it from, you could integrate our velocity function from 0 to 2 and be done. But, you know, this being the last part, it's not that simple. So how are we going to find what intervals to integrate over? Well, so it's traveling, it's traveling, it's traveling, and then it stops. Okay, how are we going to find when it stops? When is something stopped? It's stopped when the velocity is 0. So we have to set the velocity equal to 0. So we need t sine of t squared to equal 0. All right, when does that happen? Well, obviously it happens when t is equal to 0. So it happens at t is equal to 0. And I'm just going to draw this graph right here. Okay, so we'll put in a 0. And this is negative, and this is the positive direction. Okay. All right. I don't need to label that. Everybody knows that. Right is positive, left is negative. Okay, when else can it be equal to 0? It can be equal to 0 when sine of t squared is equal to 0. When is the sine of something equal to 0? This, again, you have to know this. You have to memorize this. When is sine equal to 0 on our interval 0 to 2? It's equal to 0 at 0, but it's also equal to 0 at the point pi. And we can include pi for this reason. We're not actually asking when sine of t is equal to 0. We're asking when sine of t squared is equal to 0. So really, we're asking when does sine equal 0 on the interval from 0 to 2 squared. So when does sine t squared equal 0? Well, sine equals 0 when the argument inside here is equal to 0, is equal to pi, is equal to 2 pi, 3 pi, 4 pi, etc. The one we're interested in is, the ones we're interested in are 0 and pi. So if we had t squared equal to pi, it would also, then sine of t squared would equal 0. So if t squared equals pi, then sine t squared equals 0. All right, well, if t is equal to the square root of pi, then sine t squared is equal to 0. So, at what t value does this thing stop moving? At t is equal to square root of pi. So, square root of pi. All right, now, let's find what direction this thing is going in less than 0. Okay. So, well, actually, we don't need that because we're going from 0 to 2 in the positive direction. So, what is it in between 0 and the square root of pi? Let's pick an easy number. Let's pick 1. Let's see, 1, and then sine of 1. I don't know what that is exactly, but sine starts at 0 and goes up and then comes down at pi. So sine of 1 is definitely going to be positive. So we definitely have a positive value there. And then we know that sine at pi is also equal to 0, and it's going down. So sine of just a little bit past pi, which is what you'd get if you squared this square root of pi, is going to be a negative number, so you would get a negative number. And like I said, on this portion of the test, you are allowed to use a calculator. So you could plug in 1 times sine of 1 squared and see that it was a positive number and just put it in there. And then put something like 2. You could just see what it is at the end. Or maybe just a little, I don't know, anything a little bit bigger than the square root of pi, but less than 2. Plug it in, plug that value in for t into your calculator, and you'd get a negative number. Okay. So we've determined that this thing is going up, because remember, our velocity is positive, so this thing's going up from 0 to pi, and then it starts coming down from square root of pi to 2. And I said pi earlier, I meant square root of pi. So we need to integrate and add the values of 2 separate functions. We need the integral from 0 to square root of pi of v of t dt plus the integral from square root of pi to 2 of v of t dt, right? Nope, wrong. It's going down from square root of pi to 2. So we need to count this. This is going to give you a negative value. It's going down. So whatever we actually need a negative here. Because that thing represents negative movement, we need to compensate for that by putting a negative sign there. Because, for instance, if we're integrating me walking from here to here, we'll count that as positive movement. This actually, integrating from here to here, actually counts as negative. It would result in a negative value, but we need to count it as positive. So this would actually give you the correct result. So what you would do is you would integrate you would integrate our function from 0 to the square root of pi, and then subtract it when you integrated it from square root of pi to 2. And what you get, if you do that, is roughly 1.173 units. And the reason I did not actually take the antiderivative of this thing is because in our last step we already did, and I forgot to, I accidentally erased it, but it's there. What you do is you take the antiderivative of this thing, which we've already done, and then evaluate it at the bounds. Then you take the antiderivative again and evaluate it at these bounds. Yeah, and if you did that, this is what you'd get roughly. And does it ask anything else of part D? Find the total distance traveled? No, it does not. This is the total distance traveled. That is the answer to part D. So we just did question 1 on the 1999 College Board Advanced Placement Calculus AB test. The free response, the first question on the free response portion of that. Okay, that's it, guys. Stay tuned for question number 2, which will be posted shortly. Hope you enjoyed that.